Hello class, today we are talking about finding the limits of polynomials and constants as x approaches infinity. So, up to this point, we have been finding the limits of functions as they go to a specific value, right? As x approaches 2, as x approaches 4, as x approaches -8, something like that. Well, we can also determine limits as they approach infinity and negative infinity. I should probably say that as well. So let's kind of go over polynomials for a minute. So a polynomial is just a function that has more than one term to it. And let's recall what a degree is. You may have heard it, a degree, like a degree of a polynomial. The degree is the highest power in a polynomial. So for instance, in this quadratic, the highest power is 2, so we would call this a second degree polynomial. Now, why is that important? Well, the degree of a polynomial affects its end behavior. And the end behavior is what happens to a function as we go very far right and what happens to a function as we go very far left. Maybe how far? Maybe infinity, and maybe negative infinity to the left. So as x approaches positive and negative infinity, we're really determining what its end behavior is happening, or what its end behavior is doing. We want to ask ourselves, what is happening as we take this function very, very far to the right, and as we take it very, very far to the left? And specifically, what value is that approaching? That's the limit, right? We'll never actually reach infinity. So the limit, the concept of a limit works there too. Now, this end behavior of degreed polynomials, this is a great thing to write down your notes. Well, I guess all of it's good to write down your notes. But this will help you with today's worksheet. So we have the degrees, we have even degrees and we have odd degrees, right? Odd numbers are 1, 3, 5, 7. Even numbers are numbers that are divisible by 2, right? 2, 4, 6, 8, 10. And what I mean by positive and negative is if the leading term, if it's positive or if it's negative. So basically if there's well, there won't be a plus out front, but if there's nothing out front, it's a positive. If there's a negative out front, it'll be a negative. For instance, this is a positive polynomial because there's no negative out front. If there was a negative, it would be right up here, okay? And that'd be a negative. So this function actually right here is a positive even because it's positive out front and the highest, or the degree, the highest power is an even number. So the end behavior of this polynomial would look something like this. Both ends would go up in either direction as we approach, and I should probably write this, positive and negative infinity, right? Now, say if there was a negative out front, then both ends would go down. They would approach, well, they would go down forever, right? So let's think about this. Let's go through some examples here. And let's keep this in mind, all of this. So, let's take a look at the limit as x approaches infinity of x, okay? So let's first determine, is this positive or negative, and is it even or odd? That's going to help us determine what its end behavior is going to be. Well, when there's no power written, it's technically to the first power, right? That's always implied, something to the first power. So, this is going to be an odd function because its degree is odd, and it's positive. It's non-negative. There's not a negative out front. So it's a positive even, or sorry, a positive odd. So we know the end behavior is going to, as we go to the right, it's going to go up forever, and as we go to the left, it's going to go down forever. And we know that if we were to graph the function x, right, it's just a straight line that goes like that, right? In fact, straight line that just looks just like that, right? So the end behavior, as we approach infinity, well, as x approaches infinity, so as we go far and far to the right, we need to ask ourselves, what is y approaching? What is f of x approaching? And that's really what the limit is. It's a y value, isn't it? Well, we can't really put a value on it because the further we go right, the higher it goes, right? So if the x is approaching infinity, then the limit as x approaches infinity is also going to be infinity. Now, it's a positive infinity because we're going up. What if, on the other hand, the limit as x approaches negative infinity of the function x? Let's see if this camera will focus here. Ooh, come on, focus. There we go. The limit as x approaches negative infinity. So that means we're going to the left here, right? And as we go to the left, what is happening to the function? Well, the function goes down forever. So the limit as x approaches negative infinity of the function x is going to be negative infinity because it's going down. Now, don't get confused with this infinity and this infinity. The infinities here in blue are these x infinities, right? These, on the other hand, are our y infinities, because we have infinity in 4 different directions: positive x, positive y, and negative y. So this is saying, as x approaches positive infinity, our y value is approaching positive infinity. As x approaches negative infinity, our y value is approaching negative infinity. That's our limit. Okay? So let's go into this next example. The limit as x approaches infinity of 4x squared plus 3x minus 5. Well, let's determine, is this positive or negative, and is it even or odd? And this is going to be an even, a positive even, which, if we were to look on our function, positive even goes up like this and up like this. Now, different things may happen in here in the middle depending on what's going on, but this is just the end behavior. So, as x approaches positive infinity, well, we're trending up. Y is also going to be approaching positive infinity. That's our limit there. And what about the same function if we take it towards negative infinity, as we take it towards the left? Well, it's still trailing up, isn't it? So, because it's even, it's also going to approach positive infinity. All right? What about this one down here? Now, this is a cubic. It's a cubic function, so its degree is 3. And it's also negative. So it's a negative odd function, which means that our right side is going down and our left side is going up. So as x approaches positive infinity, our y value is going down and it's approaching negative infinity. Just as simple as that. And then as the limit as x approaches negative infinity, as we go to the left, well, our function is going up. So our function is approaching positive infinity. Okay? So that's how we determine end behaviors of polynomials. Now, polynomials, the end behavior will always just be positive or negative infinity. You just have to determine which way it's going. This is a great tool to use. So determine it's positive or negative, and then determine if it's even or odd, and then use this chart to your advantage. Now, in the title, I have it as find the limits of polynomials and constants. Well, constants are really easy. I'm just going to cover it right here for a second. Think about the constant function, for instance, y equals 4, like this example here. Well, 4 is 1, 2, 3, 4. That's going to look something like that, isn't it? It's just a straight line, or a flat line, rather. Now, our constants, will they approach infinity or negative infinity in the y direction? That's a question we need to ask ourselves. No, in fact. It will never reach infinity. We have a specific value that this thing is approaching as x approaches infinity. And maybe I shouldn't use the word approaching. Maybe I should say as x approaches infinity, this value remains a constant value of 4. Right? It's never changing, this value. It's just always 4. Now, as x approaches negative infinity, as we go further and further and further to the left forever, what is the limit there? What value is it? Well, no matter where we are, it's still going to be 4. So, the limits of constants are just themselves. Okay? Just as they were when we were finding specific, or limits of specific values. Okay? So, that's all I have for y'all. Have a great day. Let me know if y'all need any help, okay?